In less than 2 years since launching, the James Webb Space Telescope has changed the way we understand the universe. For scientists, the images it's taken offer new possibilities for astrophysics.
You won't believe what the James Webb Telescope has just captured. A monumental collision with Neptune, one of the most mysterious planets in our solar system, has sent shockwaves through the scientific community. Imagine this: a gargantuan object slamming into the ice giant, potentially changing everything we know about the planet. What collided with Neptune? And how will this impact our understanding of the solar system? Stay with us as we unpack this jaw-dropping discovery that could alter the course of space exploration forever. How the James Webb Telescope is changing the face of space travel. Launched in December 2021, the James Webb Space Telescope, or JWST, already expanded our understanding of the cosmos. With its exceptional infrared capabilities, it has never been easier to observe faraway galaxies, dim stars, and, most importantly, planets in our solar system than with this telescope. It's hardly surprising that JWST captured this once-in-a-lifetime occurrence on Neptune, a planet that has captivated astronomers for quite some time. Before JWST, most of what we knew about Neptune came from flybys and faraway views, which left a lot of the surface and atmosphere up to guesswork. Nevertheless, with Webb's sophisticated sensors, we have been able to keep a closer eye on Neptune. And now we have seen something truly remarkable. An occurrence that has the potential to reshape our perception of planetary dynamics in the outer solar system. Webb recorded priceless data the second this enormous asteroid slammed onto Neptune. The object's origin and its implications for Neptune's already complicated weather patterns are being investigated by astronomers who are currently analyzing the aftermath. Is the James Webb Telescope about to reveal the first of many monumental space events? The fate of the space community hangs in the balance, yet for the moment everyone is agog with anticipation and curiosity. Neptune, the mysterious giant of the outer solar system. Neptune, the blue giant, is a mysterious planet that many find difficult to understand. Neptune is a freezing, whirling planet with erratic storms and frigid winds. It is about 4.3 billion kilometers from the Sun. Few details about Neptune's atmosphere, rings, and moons have been known for generations, keeping the planet shrouded in mystery. The James Webb Telescope, however, is allowing us to uncover more and more about this faraway behemoth. Because of the chaotic mixture of hydrogen, helium, and methane in Neptune's atmosphere and the rarity of such events, scientists were astonished to hear about the impact when it was identified. Earth might face disastrous repercussions if a huge object were to reach this unstable region. Initial evidence points to the object possibly altering Neptune's atmosphere, which in turn could have triggered enormous storms that are currently under investigation. Neptune has long been an intriguing celestial body due to its remote location in the solar system. It stands out from the other planets due to its enormous size, powerful winds up to 2,100 kilometers per hour, and intricate ring system. Now that the James Webb Telescope has found this frozen giant, our entire understanding of it must be re-evaluated. Would this impact provide light on the secrets and inner workings of Neptune? What collided with Neptune? The most pressing concern regarding this incident is naturally the nature of the object that slammed with Neptune. Could it have been an escaped Kuiper Belt asteroid, a stray comet, or even an artifact from when the solar system was still in its early stages? While data analysis is underway, first guesses suggest the object may be an errant spacecraft from beyond our solar system. A prominent theory suggests that the object might have been a massive icy world from the Kuiper Belt, an area of space situated just beyond Neptune that contains numerous frozen bodies and dwarf planets. Although objects from the Kuiper Belt have visited our solar system before, the magnitude of this collision indicates that it was something considerably bigger than initially believed. Another possibility is that it was an interstellar object like Oumuamua, which made its way past our solar system in 2017. If this is true, it would be a major milestone in the history of interstellar contacts in the field of modern astronomy. The discovery of a huge interstellar object crashing with a major planet in our solar system would be a watershed moment in space history, ushering in an era of unprecedented opportunity. If proven to be an interstellar object, this event could spark a renewed interest in space exploration and interplanetary defense mechanisms. Scientists would be compelled to re-examine the risks posed by rogue celestial bodies, especially if such objects are capable of causing significant damage to a planet like Neptune. Furthermore, this discovery may lead to advancements in understanding the nature of interstellar objects and their potential frequency in our cosmic neighborhood. Ultimately, this incident could reshape our approach to space monitoring, emphasizing the importance of detecting and tracking foreign objects entering our solar system. What we know about the impact aftermath. The hit created a huge disturbance in Neptune's atmosphere, according to preliminary data from the James Webb Telescope, which scientists are still studying. The planet's cloud formations appear to have strange patterns in some of the first pictures, which may signal a change in the planet's already severe weather systems. Would Neptune's storm systems and magnetic field have been permanently altered as a result of this impact? The impact on Neptune's rings is one of the intriguing parts of this event. The rings of Neptune are nevertheless the object of extensive research, despite the fact that they are far fainter than Saturn's. As a result of the collision, debris may have entered Neptune's ring system, altering or forming new rings, according to some experts. Any changes to Neptune's rings could shed light on the dynamic nature of planetary ring systems, which has been a mystery since their discovery. Thus, this is quite important. Neptune will undoubtedly change as a result of this encounter, but what happens afterward is unclear. For the time being, researchers will keep an eye out for any changes to the planet's atmosphere, new storms, or ring changes. This could be among the most fascinating astronomical discoveries of this decade, yet it's only the beginning. How supernovae affect planetary development. Our solar system has a long and storied history of cosmic encounters. Such events have really molded numerous worlds, Earth included. For instance, the conventional wisdom is that our moon was formed billions of years ago when a large celestial body slammed into Earth. It is also believed that a massive object struck Mars, causing its surface to shift dramatically. On the other hand, Neptune has long been considered a solitary planet. It is less likely to encounter stray objects than planets like Mars or Earth because of its location in the outer solar system. However, the most recent collision casts doubt on that notion and serves as a reminder that not even the farthest worlds are safe from the influence of the cosmos. New questions regarding the impact of collisions on the formation of Neptune and other faraway planets in our solar system are prompted by this event. Is it possible that Pluto or Uranus are experiencing similar phenomena? Do these kinds of collisions happen often in the course of planetary evolution, or are they unusual? If these questions have their answers, we may have a clearer grasp on the cosmic events that shape planets' evolution. The impact on Neptune's moons. Scientists have always been captivated by Neptune's moons, particularly Triton. The biggest moon of Neptune, Triton, is unusual among the planet's 14 known moons because it follows a retrograde orbit, which is counter to the way Neptune rotates. So it's possible that Neptune's gravity once ensnared Triton, an object that was once on its own. After a massive object slammed into Neptune, researchers are keen to learn what effects, if any, the collision had on the planet's moons. Specifically, many consider Triton to be one of the solar system's most geologically active moons due to the presence of unique terrain and frozen geysers on its surface. Have other volcanic or geological eruptions occurred on Triton as a result of this impact? On the other hand, is it possible that the impact altered the moon's orbit and its future course? Astronomers studying the aftermath are currently focusing on these questions. Furthermore, the impact's shockwave may also influence Neptune's smaller moons, which are in closer orbit to the planet. We may see alterations to the moon's surfaces or even changes to their orbits if the collision debris reaches them. Investigating these moons after an impact could provide a unique opportunity to learn about the effects of cosmic collisions on gas giant satellites. Planetary defense systems and consequences. Planetary defense is of the utmost importance in light of the impact with Neptune. Although Earth was not in danger when the asteroid hit Neptune, the incident is a sobering reminder of the continual motion of space objects and their capacity to produce devastating harm. A crucial question that follows is whether or not such an impact could occur in our own backyard, and whether or not we are ready for it. Detection and deflection of potentially hazardous objects have been the focus of recent investments in planetary security measures by space agencies like NASA and ESA. This brush with Neptune highlights how important it is to keep an eye out for space debris that could end up in Earth's orbit. The effects on Earth of a collision with an object of a comparable size would be catastrophic, particularly if it were to strike a heavily inhabited region. The impact has rekindled conversations about creating early warning systems and technology that could shield Earth from a similar catastrophe. Projects such as NASA's Double Asteroid Redirection Test aim to evaluate our capacity to redirect an approaching object. But, as the Neptune crash demonstrated, the size of objects in space can vary greatly. Would we have to re-evaluate our strategy if we attempted to use our present planetary defense systems to intercept objects of a larger size? Is it possible that the impact might change Neptune's orbit? If the impact were that powerful, it would change Neptune's orbit, which is one of the main worries caused by this collision. Despite Neptune's size, which is roughly 17 times Earth's mass, its orbit around the Sun is vulnerable to perturbations. Would Neptune's position in the solar system be altered by this impact? Although it was big, the object probably wasn't massive enough to drastically change Neptune's orbit, according to the available data. But in the days, weeks, and months after the crash, scientists will be watching the planet's motions very carefully. Small shifts in Neptune's orbit may cause bigger alterations in the solar system's outer dynamics. Many objects in the Kuiper belt, for example, have their orbits influenced by Neptune's gravity. Alterations to its orbit have the potential to upset the careful equilibrium that maintains the courses of these objects. It has long been believed that Neptune's position in the solar system acts as a guardian by diverting comets and asteroids away from the inner planets. This protective role might be affected by any change in Neptune's orbit, which would alter the dynamics of object paths across the solar system. The possibility of subsequent crash. Doubts regarding whether the Neptune impact was an isolated incident or a trend of cosmic collisions in the solar system's outer regions have been voiced in response to the event. Do you think there might be other objects headed straight for Neptune or other gas giants like Uranus? In an attempt to discover any possible dangers to the planets, astronomers are currently concentrating on monitoring the motion of objects in the Kuiper belt and beyond. Objects in the Kuiper belt may have more unpredictable courses when they interact with Neptune's gravity, according to one popular theory, which increases the probability of collisions. If that's the case, Neptune's atmosphere, rings, and moons might be in for some major changes as a result of a new period of cosmic hits. This begs the question, are other gas giants like Saturn or Uranus on the brink of a comparable catastrophe? The study of these collisions gives vital insight into the behavior of objects in the outer solar system, even though future encounters won't directly affect Earth due to Neptune's distance from us. If we can figure out what causes these collisions, we can better prepare for future hits and maybe even protect our world. Future space exploration in light of this. More people are interested in looking for planets outside of our solar system after this impact with Neptune was detected. Mars, Venus, and the Moon have long been given higher priority than Neptune and Uranus missions. Nonetheless, this occurrence has the potential to alter that, reviving enthusiasm for dispatching probes or perhaps human trips to the icy giants. Researchers are urging for new exploratory flights to Neptune using data from the James Webb Telescope. However, neither NASA nor the European Space Agency currently have any active missions to the planet. Our best bet for deducing the mechanisms that form the outer planets, their moons and rings, is to examine Neptune and its most recent collision. By delving into these processes, our understanding of the solar system as a whole will be enhanced, and our ability to research exoplanets like Neptune will be facilitated. Astronomers have a rare chance to explore the instantaneous aftermath of a cosmic event on a gas giant thanks to the recent collision. This has the potential to increase support for missions that would take us to these faraway worlds for in-depth exploration. How the James Webb Space Telescope is bringing light on new enigmas. The groundbreaking capabilities of the James Webb Space Telescope were crucial in revealing the Neptunian collision. The JWST has provided a deeper and sharper perspective of the cosmos than any human has ever seen since it was launched. In the span of a few short years, it has revolutionized our understanding of space by its unparalleled clarity in observing faraway planets, stars, and cosmic events. On the other hand, what role did the JWST play in detecting this historic occurrence? The JWST is able to detect thermal emissions that are invisible to the naked eye by using its infrared capabilities to peek through Neptune's thick atmosphere. A surge of energy and heat was released at the impact, which the telescope detected instantly. This finding gave scientists a better idea of the object's size and speed when it impacted with Neptune, which helped them figure out what it was made of. In addition to confirming the impact, the JWST is keeping a close eye on Neptune's atmosphere to analyze any changes that may have happened post-collision. The reaction of the planet's climate to the occurrence is of great interest to scientists. The atmosphere of Neptune is notorious for its violent weather, with gusts of more than 1,200 miles per hour. These weather patterns could shift as a result of the impact, and the JWST will play an essential role in monitoring any such changes as they happen. With its improved detection of collisions, observation of atmosphere changes, and data gathering on faraway objects, the telescope has paved the way for a better understanding of the outer planets and will keep space exploration moving forward. Neptune's post-collision atmosphere in more detail. The atmosphere of Neptune has long fascinated astronomers. The main components of this gas are hydrogen, helium, and methane. It has a striking blue hue and is associated with intense weather systems. A planet that was previously shrouded in mystery has become even more so after the recent collision. But what precisely is going on in Neptune's atmosphere after the impact? And how can we deduce anything from these alterations? Significant disruptions in the planet's upper atmosphere have been identified by astronomers following the collision. The impact's tremendous energy wave reverberated through the sky, changing the planet's weather patterns. The collision may have caused new storms to form or amplified existing ones, even though Neptune is accustomed to severe weather. We may witness the emergence of unprecedented superstorms as a result of this. The collision may also bring in foreign matter that could alter Neptune's atmosphere in the long run. A lot can be learned about the item, and about how the atmosphere of Neptune reacts to outside influences from studying the gases and particles that were produced during the impact. The planet's deeper strata, which are inaccessible to most people, may also be illuminated by this data. We may learn more about the nature of gas giants and Neptune in particular by watching its changing atmosphere over the next few months and years. The collision's potential ripple effects on other worlds. Although this cosmic event primarily concerns Neptune, the collision's consequences may go well beyond the blue planet. When it comes to the solar system's gravitational dynamics, gas giants like Neptune are vital. Gas giants are like shields. They absorb or divert anything that may harm Earth or Mars, as we saw with Jupiter shielding the inner planets from asteroid collisions. But if one of these gas juggernauts gets struck, what will happen? Might this throw off the careful gravitational equilibrium of the solar system's periphery, influencing the paths of planets and other celestial bodies? While the impact is having a noticeable impact on Neptune right now, other scientists are concerned about potential long-term impacts that are still unclear. The possibility that other objects may be pursuing a similar course is cause for concern if, for example, the object that impacted with Neptune originated in the Kuiper Belt. The moons of Neptune could have their orbits disturbed, or even Uranus and its system could be affected if there are more massive objects hurling toward the outer planets. The gravitational pull of Neptune on faraway solar system objects, such as dwarf planets or comets, may be altered by these cosmic waves. Scientists are now keeping a careful eye on the motions of objects in the Kuiper Belt and beyond to evaluate the wider ramifications of this event, the entire impact of which may not be understood for years or perhaps decades. Looking back at collisions, what sets this one apart? Although the revelation of the crash with Neptune is revolutionary, huge impacts on gas giants are not new. Comet Shoemaker-Levy 9, which collided with Jupiter in 1994, is one of the best-known examples. A number of tremendous explosions occurred on Jupiter's surface as a consequence of that event, and scientists learned new things about gas giant collisions as a result. What sets this event apart from others, and how does it compare to the Neptune collision? To begin, observing Neptune is very difficult due to the planet's great distance from Earth. Neptune is situated farthest from Earth in our solar system, in contrast to Jupiter, which is considerably closer to us. This hinders the ability to observe in real time, and prior to the JWST, we did not have the equipment to track Neptune as precisely as Jupiter. Modern space observation technology is responsible for our ability to identify this collision. Furthermore, Jupiter's atmosphere and Neptune's are very different. Even while both Neptune and Pluto are gas giants, a collision between the two would take place in a completely different setting due to Neptune's distinct makeup, weather patterns, and moons. This encounter will likely have a different impact aftermath than Jupiter's, providing scientists with fresh information about the reactions of different gas giants to cosmic events. The objects that occupy the solar system's furthest reaches are also the subject of fresh inquiries brought up by the collision. Was this an isolated incident, or would Neptune be more susceptible to collisions with objects farther away because of its position? Our knowledge of planetary impacts in the outer solar system could be transformed if new trends and patterns are revealed as we keep comparing this collision with previous occurrences. The post-collision function of Neptune's moons. Although Neptune has received the lion's share of attention, the moons of the planet, especially Triton, may hold the key to unraveling the catastrophe's complete consequences. Triton is the largest and most interesting of Neptune's 14 known moons. Triton is unique among the solar system's moons in that it follows a retrograde orbit around Neptune, meaning it travels in the opposite direction of the planet's rotation. This has perplexed scientists for a long time, and some have even proposed the idea that Neptune once grabbed Triton from the Kuiper Belt. The most recent impact might have far-reaching consequences for Triton and the other moons of Neptune. The gravitational equilibrium between a planet and its moons can be upset when a large object crashes into a gas giant. Minor changes to Triton's course are possible given the planet's peculiar orbit. Since this changes the tidal forces between Neptune and Triton, it may influence both their positions and surface activities. In addition, information on Neptune's other, less well-known moons may be uncovered by the crash. By keeping an eye on how these smaller moons react after an impact, we may learn more about Neptune's satellites, which are more susceptible to gravitational disturbances. Researchers may learn more about the moon's dynamics and interactions with Neptune's gravitational field if their orbits were to undergo even minor alterations. The larger impacts of the collision will be better understood if scientists keep an eye on Neptune's moons over the next few months for any changes or unusualities. This continuing investigation will shed light on the behavior of moons orbiting other gas giants in the cosmos and will aid in our understanding of Neptune. Could this occurrence modify what we know about gas giants? The finding of the Neptunian collision may need a rethinking of our current understanding of gas giants. Planets such as Jupiter, Saturn, Uranus, and Neptune have long been considered as spherical bodies that experience severe weather events with minimal widespread disturbances. But this stuff happens, and it makes you wonder if gas giants can survive big hits. This incident begs the question, how often are these kinds of collisions, among others? When does Neptune and other gas giants get hit by big objects? And why haven't we noticed more of these collisions before? We now have new eyes in space because of technological advancements, especially the James Webb Space Telescope, which allows us to observe things we couldn't see before. These collisions might not be as uncommon as we once believed as time goes on. The collision may also encourage scientists to investigate gas giants' interiors further. The precise composition of the cores of these planets is unknown, although we do know that hydrogen and helium make up the majority of their mass. This kind of event has the potential to teach us a lot about the makeup of Neptune's interior layers, which will aid in our attempts to simulate the world behind its thick clouds. More information on the evolution of gas giants may be revealed by this collision. Are they able to withstand repeated collisions, or do they alter their interior structures and atmospheres? Finding the answers to these questions could change the way we think about gas giant evolution and planetary formation in general, not only in our solar system, but in the galaxy at large. Neptune and the solar system beyond. What comes next? Scientists are currently concentrating on the following steps for Neptune and the solar system beyond the immediate aftermath of the crash. Is this going to be the first of many cosmic collisions? Or is it going to be an isolated incident? Neptune and the far corners of our solar system are still mysteries, but scientists are starting to piece together their future with the help of new evidence. The long-term observation of Neptune's atmosphere is one of the main objectives. The impact may have brought new components that change the world's climate for years to come, adding to the already notoriously unpredictable weather patterns of the globe. Scientists intend to learn more about the impact of such collisions on the atmospheric conditions of gas giants like Neptune by keeping an eye on the planet with the JWST and other observatories. Also, the Kuiper Belt, a solar system area rich with dwarf planets and other frozen bodies, is getting a lot of focus. More massive objects may be on the same trajectory as the one that hit Neptune if it came from the Kuiper Belt. All the outer planets, including Neptune and maybe even Earth, are affected by this. Predicting future occurrences and protecting our planet will depend on our ability to understand the dynamics of the Kuiper Belt. Research into Neptune and its most recent encounter may also pave the way for other exploratory initiatives. There hasn't been a mission specifically designed to study Neptune, even though NASA's Voyager 2 collected useful information about the planet during its 1989 approach. Recent developments may rekindle the idea of sending a spacecraft to Neptune for further exploration of the planet, its moons, and its atmosphere and interior structure, in addition to studying the consequences of the collision. The urgent need for space defense. This Neptune impact and others like it are demonstrating the increasing significance of planetary defense as our space exploration activities progress. The crash with Neptune was a reminder of how unpredictable space can be, even though the object didn't threaten Earth. There are thousands of objects in Earth's solar system, so it's only a matter of time until another one, perhaps dangerous, is about to smash into one of the planets or even Earth itself. More funding for space defense plans has been demanded again since the Neptune collision was found. A huge accomplishment in this field was the 2022 Double Asteroid Redirection Test mission, which tested deflection capabilities by impacting an asteroid. More extensive detection and deflection systems are required, though, in light of recent events surrounding Neptune. Important information about the behavior of things when they strike a massive body can be gleaned from observing Neptune's crash. With this information, future planetary defense programs will be better able to foresee how asteroids and comets may affect Earth. Our aim is to develop a reliable system that can identify any dangers in plenty of time before they reach Earth, allowing us to respond accordingly. Protecting Earth is becoming an increasingly critical issue as space exploration progresses. The Neptune crash should be seen as a wake-up call and a chance for humans to get ready for the difficulties that come with space. The ever-continuing search for cosmological understanding by humans. Our species' never-ending pursuit of cosmic knowledge includes many more chapters than the one involving the crash with Neptune. Whether it's a black hole, an exoplanet, or a huge impact on a faraway planet, with each new finding we get closer to the age-old question: how did the universe begin? How many people are here? When we look up into the sky, what laws control the many celestial bodies? The enormousness and unpredictability of space are shown by the recent Neptune occurrence. Even though we have come a long way in space travel, it serves as a reminder that there is a great deal more to learn. New discussions regarding planetary systems, gas giants, and the solar system's continuous evolution have been initiated by the collision. Remember that every discovery, no matter how far away, has the potential to impact life on Earth as we continue to explore, observe, and ask questions. Space exploration is still one of humanity's top priorities, whether for the development of new technologies or the protection of Earth from interplanetary dangers. One example of how far science and technology have come is the James Webb Space Telescope's ability to detect the Neptune collision. It serves as a reminder that we can reach even the farthest, most enigmatic parts of the cosmos, and the secrets that have captivated humanity for ages are becoming easier to decipher with each new finding, a galactic clash with limitless opportunities. Not content to be merely another astronomical occurrence, the discovery of a huge object crashing into Neptune is a deep enigma with the power to change the way we perceive the solar system's outer regions. Humanity may now see into the universe's governing forces thanks to the James Webb Telescope's unparalleled capacity to collect such details from deep space. We don't yet know what this collision means, but it makes us wonder where these things came from, how they may have shaped our cosmic neighborhood in the past, and how stable the farthest frontiers of our solar system are. Nobody can say for sure what will happen next. It is possible that new astronomical phenomena could be revealed, or that hypotheses on the formation of planetary systems will be revised when astronomers from around the world examine the data. Every new finding, like this collision, expands our understanding of the universe, and the James Webb Telescope is transforming our perspective on the cosmos. What do you think this colossal collision could mean for the future of space exploration? Could it unveil secrets about our solar system's hidden past? Share your thoughts in the comments below, and make sure to subscribe for more updates on mind-blowing cosmic discoveries. And before you go, don't forget to watch our next video on more incredible breakthroughs from the James Webb Telescope.